So let's talk about the radius of gyration. Just continue from the previous video. And as you can see, for the equation of the mass moment of inertia, it's different from shape to shape, different standard shape, different. But you see the pattern. For example, there, for the sphere, you have 2/5 of mr squared. For rings, you have mr squared for IZZ, for the y-axis and x-axis 2 mr squared. So as you can see, the pattern here is one factors, one coefficient times mr squared. So with that, to simplify the mass moment of inertia, they introduce a new concept that we call it radius of gyration. So let's talk about the radius of gyration. Radius of gyration. What is that about? It's purely a geometry property of a body. So basically, it's a geometric property of a body. So nothing to do with the physical properties such as the mass, the density of the body. So as you can see, if we talk about physical properties, it means that we talk about the iron or steel. It's different from the aluminum, different from plastic, that we call physical property. But this is purely the geometric properties of a body. So from that, what I showed you, that equation, we have defined the K, that is the radius of gyration, K in here. So K lowercase equal to square root of mass moment of inertia divided by the mass. So when you define that as the radius of gyration, then we can have I, just square both sides and kick m up. So I have I equal to m k squared. So that, and you can see that the pattern I just showed you for different standard shape in the equation that have a coefficient m times r squared. And then now we forget about the coefficient. Let's put together that we call it the k squared, and that is the radius of gyration. So let's box that equation here. So whenever the problem give you the radius of gyration, you don't need to go to the standard shape, the inside cover of the book to find out the I. Just apply mk squared. You can find out. So in that case, you can see k lowercase in this case is radius of gyration, and that purely a geometric properties of the body. And whenever the problem give you the radius of gyration, just go ahead to time m k squared to find out the mass moment of inertia. And in the next 3 problems for today's class, we will use the table that I show you in reference data card section 12 to find out the center of mass and then the mass moment of inertia. And we also apply the parallel axis theorem with the table there for the coming problems, problem 1, problem 2 and 3, that, and also the radius gyration in the problem demonstration. We don't have that here, but when you apply in the force acceleration, work energy and impulse momentum in the next 9 classes, you will see the radius of gyration. So by now, remember what is radius of gyration and apply that in the next class. With that, let's move on to the solution of the